Hey everyone. I'm Lieutenant Gregory Clark. I work in the Mech and Aerospace Engineering Department, and we'll be going over some engineering safety standards, risk assessment, hazards, so on and so forth today. For your professional development course, obviously. So, yeah, objective of this particular lecture is to acquire a basic knowledge for engineering safety standards and what sort of responsibilities you as an engineer are going to have towards various segments of the public. So references are going to be from Canadian Professional Engineering and Geoscience Practice and Ethics textbook. Uh, um, and we'll be talking about duty of care is one of the most important concepts you can have. So it's a legal concept. So basically saying that when there's certain things that you can do that basically mean that you have a responsibility towards others in order to do those things properly, even if you don't necessarily have some sort of contract with them stating, yes, I will do this in this manner. So the classic example is you are driving on a highway. You have a duty of care to avoid injuring others, damaging their vehicles, so on and so forth. You are required by law in order to drive in a safe manner, and if you fail to do so, then you can be sued as a result. So duties of care are owed to basically anyone who is likely to be injured by a potentially dangerous act that you do. So sometimes that can be immediate effect, car crash, obviously. Sometimes the dangerous act can occur years down the road. So if you design a building poorly and that building collapses down the road, then you can still be held liable for that. So, as engineers, when you're designing a device, structure, so on and so forth, you owe that duty of care to basically anyone who comes in contact with the structure or device. So, again, immediately or years down the road, or so on and so forth. So, the concept of the standard of care that you need to provide is kind of based upon, like a lot of things in law, a reasonable person test. So basically, the idea is, um, you know, whether or not a reasonable person with design, like a reasonable, uh, based upon whether or not like an engineer who is um, educated to the same amount, following established practices, would make similar decisions to what you make. So you're not when we say a reasonable person, it doesn't necessarily mean what a lay person would do. It means basically that standard of care is based upon a reasonable member of the group that you belong to. So, for example, like a doctor's actions in a malpractice suit is going to be based upon whether or not another doctor would reasonably make the same decisions they did. Uh, it's not going to be based upon whether or not the medical advice they provided would be the same as what your mom on Facebook might recommend. Unless your mom's a doctor, but anyways. So if you are negligent, then then you can be sued in court. So if you were the one who caused harm um, due to something that you did, so the harm was due to you, and that harm wouldn't otherwise have occurred, then again you can be found negligent in court and sued as a result. So, as an engineer, you are obligated to act in an ethical manner, avoid negligence and incompetence, and eliminate hazards before the products enter the marketplace. So a few reasons that someone might be able to come after you or the whoever you happen to be working for a product that is faulty. Could be defective manufacturing occurred, poor design, or if there were dangers associated with the product that you failed to warn your customers of. Now, that doesn't necessarily mean that dangers, the fact that there is a danger or hazard associated with the product does not necessarily mean that you can't produce that product. After all, there's very few products that are completely inherently safe no matter what the circumstance is. Um, but, I mean, cars when used when used properly, uh, are relatively safe, but when used improperly, uh, are quite dangerous. And that's why stuff like owner's manuals are issued with the car in order so that the people who are using the product will know how they're supposed to use this product in a safe manner. So some other some things that may need to be done. You may need to do a risk utility analysis. So basically, if you want to do something that increases the risk of using a product, then you need to balance that against, you need to balance the utility of that thing versus the risk. So an example here, if you have truck headlights that were on the same circuit, um, then basically what that would do is it might simplify your design a little bit. It might allow you to save, you know, a bit on the cost of producing the car, but in the event that you had a problem with the headlight that knocked out one of them, then basically you'd end up having both headlights go out, which of course would be uh, bump the risk level up beyond the point where that would be acceptable, uh, or at least certainly the additional risk doesn't outweigh. It is not. It is too high to justify when the utility would just be saving a bit of money on manufacturing costs. So throughout this lecture, we'll also be uh, I'll be showing a few. Well, I'll be having you guys watch a few videos. So I'll be providing the links to the videos in Moodle there, and I'll give you guys a bit of time to go watch this. So go ahead and watch. Go ahead and pause this video. Go watch that video on YouTube, and then we'll come back. So give me a bit of time here. All right. So one of the things that video kind of highlights is that it's not only just the design that's used that's important. The implementation is fairly important as well. So like the product needs to be made to spec. So if the spec is poor, then obviously if the design's poor, then obviously failure is more likely, catastrophic failure is more likely to occur. But if you can have a proper design that gets implemented in a shoddy manner by whoever's making the thing, that can also lead to disaster as well. So as engineers, one thing that you should do is also emphasize when things are very important, emphasize the critical points, and also do proper hazard analysis for your product. You know, making sure that you have a good idea of how things could go wrong. Failure analysis may be required as well. So again, if you have like a component that might fail, then you need to determine the impact that component failing would have on the entire system. Sometimes the systems that you're using are simplistic enough that a full-on failure analysis might not be all that useful. I mean, for example, my coffee mug here. If something breaks, that's the problem. It's not necessarily going to cause some sort of cascading failure. So some methods that can be used for failure analysis. One method that can be used is failure modes and effects analysis. So basically, we're looking at kind of rating the severity of the potential failures and the occurrence rate, and as well our ability to detect such failures. So basically, if it detect such failures before it causes a problem. So for example, if you have oh, what am I trying to say here? If you have, for example, a turn signal indicator that goes out, then many cars will if you attempt to turn the turn signal on, will give you an indication that when your turn signal lights is out by giving an audio signal to the user, so that can detect your failure and reduce the chances that it's actually going to lead to an accident occurring due to you seemingly not using your turn signal from the perspective of other cars on the road. Fault tree analysis. So that's kind of looking backwards after a fault has occurred, trying to analyze what happened in order to allow us to figure out, all right, what the problem was, and then go about fixing it. And one thing here, when in doubt, lean towards increasing safety. So manufacturers who are making things, they have a responsibility to, focus on safety as a policy. So not just from the design perspective, but also quality assurance. So we need to make sure that the stuff that we're sending out of the factory is up to the specs mandated, so that making sure that the components are strong enough, or made of the right material outlined in the spec, so on and so forth. So we need to test them, and the degree to which they need to be tested will be determined based upon how important this thing failing might be. So for example, if you have the testing for, I don't know, a component that's going to be used to attach the wings of an airplane to the fuselage, then the quality assurance regime for that component is going to be a lot more important than, say, the quality assurance required for a rubber chicken leaving the rubber chicken factory. Because if a rubber chicken fails, then it doesn't squeak when you squeeze it. And beyond that, no one really cares. It might be bad for the reputation of the rubber chicken. Might get a few bad reviews on Amazon, but oh well. No one's going to die because the rubber chicken didn't squeak properly. So, also, making sure your published material is proper. So, adequately warning people of the risks, determining, to what degree you're warranting your products, so on and so forth. If you are getting customer complaints, you do have a responsibility to act upon those. So if something's breaking in a manner that you didn't anticipate, then you should fix that. And of course, if those problems are popping up enough, then you may need to do some sort of recall in order to fix the problem, or at least warn owners of the problem. So I'll have you watch the Space Shuttle Challenger disaster major malfunction video, which is a wholly depressing look at how an organization which had previously had a fairly good reputation for fairly good reputation for safety, managed to ignore a fairly important warning uh, from an engineering team. So I'll let you watch that. Okay. So standards come into play a fair amount, so that different industries will have different standards that you need to meet. So there may be, if you're working in the pipeline industry, there's going to be certain standards for like what type of material you need to use, how thick how thick it needs your pipes need to be based upon what sort of pressure you're using, so on and so forth. What sort of inspection routines you're supposed to do. Standards Council of Canada is the primary one that works with consumer goods in Canada. There's also the International Organization for Standardization. So they publish standards which are used across a wide variety of industries. So there's quite a lot of ISO standards that you can adhere to. Some would be applicable for different types of things that you're going to be doing. So one of them, the ISO 9001 standard, it's the Quality Management and Quality Assurance Standard. So often used it's used for basically managing a manufacturing corporation with the goal of maximizing the quality of its manufactured products, with an aim at kind of not only just starting with a good product, but also increasing the quality and increasing safety over time. So in order to do so, basically the corporation is expected to kind of monitor all aspects of its business, so for management, handling, storage, etc. So it's expected to develop processes that to be followed, and also processes to improve the processes over time. And then, of course, you can't just put policies in place and then ignore them. So audits need to be done, internal and external audits done on a regular basis that will help us to ensure that we're following the process, basically. And then the ISO 14,000. So these are environmental management systems. So the aim here is to minimize the impact of your operations on the environment. So preventing pollution, doing the best to ensure that we're not killing off the planet any faster than we well, not killing off the planet. Ideally not killing off the planet at all, but obviously I would like to emphasize that there are no industrial processes that have no environmental impact. You can't make anything without damaging the without affecting the environment to some degree, and the goal here is to ensure that we're minimizing the damage we cause, while still allowing us to do whatever it is that we're trying to do. So through this, there's going to be certain like emission levels that are allowable, that are set by regulatory agencies, and so on and so forth. So the ISO 14,000 standards will basically be used to help us ensure that we are keeping up with those standards. And then, so government organizations can publish standards. So like the SCC, the ISO can as well. So that's a non-government organization. There's various engineering societies that publish standards, ASME, IEEE, ASTM, so on and so forth. And then some of these, of course, will have the weight of law behind them. So, like the National Building Code, the National Fire Code, so on and so forth. You're required to adhere to these standards, whereas some of these listed may just be best practices. That having been said, you can absolutely be sued if you fail to follow best practices and it results in destruction of property or injury to an individual. And then of course, we're also not worried just about protecting the consumers of our products. We're also worried about protecting our employees as well. So, Workers' Compensation Act. You can have occupational health and safety regulations. So those can be both provincial and federal. Depending upon what industry you're working in. Sectors of basically whether or not you fall under provincial or federal guidelines depends upon what sector you're working in. So, for example, railways are under federal jurisdiction, banking, telecommunications, aviation, that's all federal. Obviously, the Canadian Armed Forces is under federal regulation, although I would like to emphasize that we don't actually fall under as military members don't fall under the same workplace safety regulations that protect federal public servants. But to a large degree, the CAF does at least try to adhere to those protections for military personnel, regardless of whether or not they're mandated to do so by law. But anyways, any other sectors. So, like for example, manufacturing would fall under provincial occupational health and safety regulations. Like forestry, basically anything that doesn't fall under federal falls under the various provincial regulations. Most employees out there will be covered under provincial regulations. As well, the environmental legislation is mostly provincial jurisdiction. The primary one, the primary point where the federal jurisdiction comes into play is with stuff that could affect fisheries. And go ahead and watch this video again. This is one of the classic cases of where the system kind of fell apart during construction, and as a result, we had quite a number of people dying in the collapse. So, I'll give you a bit. Okay, so one thing I would like to emphasize here is that, all these regulations that are in place, basically none of them are proactive. Every product safety or every workplace safety regulation that is put in place is written in blood. They all get put into place after tragedy has occurred. I'm sure there's probably one or two counter examples of that not being the case, but for the most part, we're reacting to disasters that have occurred, unfortunately. So here's a few useful links for some of those organizations that I mentioned. And we'll give it a bit of, and we'll move on to the next lecture.